A very good morning to the lecturers. My name is Sharon Ting. Today I'm going to present my final year project 1 with a title, A Comparative Study Between Conventional Concrete and Concrete Made from Plastic Waste by Using SolidWorks Software. As we know, concrete plays a vital role as a construction material in the construction world due to its high strength, long-lasting, and low cost. However, the production of concrete uses all the natural resources such as fine aggregate, coarse aggregate of the cement. Then, the production of the concrete will also release the greenhouse gases such as methane gas of the carbon dioxide. When the production of the concrete increases, it also increases the release of greenhouse gases and causes the global temperature increase gradually. Thus, global warming of the climate change will occur. Meanwhile, something happened to the waste material. Large amount of waste material will be disposed of in the landfills, which results the landfills lack of space. So according to this figure, Malaysia is ranked number 8 of the top mismanaged waste in the world. The mismanaged percentage of Malaysia is 2.9%. Therefore, the production of concrete and also the large amount of disposal of waste material, the combination of these two items will result in innovative concrete, which can reduce the usage of natural resources, the reduced disposal of mass material, and also reduce the environmental issues such as global warming. Then, the innovative concrete will also result a higher strength than the conventional concrete. Therefore, the objective of this study is to determine the optimal composition of different ratios of fine aggregate plastic waste in producing a concrete by using SolidWorks software, and to evaluate the physical and mechanical properties of different ratios of fine aggregate plastic waste in producing a concrete by using SolidWorks software. Then, the third objective will be to compare the properties of concrete made from plastic waste and conventional concrete by using SolidWorks software. Next, the scope of the study is to determine the optimal composition of different ratios of fine aggregate plastic waste in producing a concrete. There are 5 samples are prepared in the study. 4 samples are prepared with a ratio 20%, 40%, 60%, and 80% of plastic waste, respectively, while a 100% of fine aggregate will be prepared as a control sample. Then, the 3D image of the samples will be designed by using SolidWorks software version 2021. Then, the SolidWorks software also used to conduct the composite strength test, drop test, and failure analysis in order to determine the properties of concrete made from plastic waste and conventional concrete. Lastly, the properties of the concrete made from plastic waste and conventional concrete will be compared. In recent years, there are many scholars trying hard to find an alternative of a replacement of concrete made from waste material. According to Mahajarani and Ramkumar, they used secret bars as a replacement in producing concrete, and they found that by using secret bars can improve the strength of a concrete. Then, according to Kumar, they used bottom ash in producing a concrete, and they found that bottom ash as a replacement of fine aggregate can improve the strength of a concrete. Then, Arif Valagan, who used plastic waste as a replacement in producing concrete, also can improve the strength of a concrete but should have an optimum value. Then, Al-Khatib and Ramkumar, who used glass as a replacement in concrete, also result in improvement in the mechanical properties, which are compressive strength, the failure strength of a concrete. Then, for the plastic, there are 7 types of plastics, and the 3 common recycled plastics in Malaysia in the world are the PET, polyethylene ceramic plastic, Type 2 plastic, HDPE, and the Type 5 plastic, the polypropylene. These plastics have their own properties and also common uses. As mentioned earlier, composite strength is one of the mechanical properties of concrete. The composite strength test is used to determine the composite strength of a concrete from each direction without any cracking. According to Ramkumar, Kumar, and Arivaragan, who used secret bars, cotton ash, and plastic waste as a replacement of waste material in producing concrete, these three materials can improve the composite strength of the concrete but should have an ultimate value. However, according to Ramkumar, who used crushed glass, he found that with an increasing crushed glass in concrete, the composite strength will also increase gradually. Then, a drop test is used to measure the durability of the material under a height or width of an impact force. So, according to Abbott, micro steel fiber, which used as a replacement in producing concrete, can increase the strength of a concrete but with a limited height. Then, according to Ramkumar, by using secret bar as a replacement in producing concrete, also can improve the impact strength of the concrete. Then, according to Ramkumar also, by using crushed glass can improve the impact value of the concrete and also improve the strength of the concrete. Then failure analysis is used to identify and investigate the reason for a failure. According to Avid, who used self-compacting reinforced concrete with microsteel fiber, they found that it will have a failure on the concrete. Then they can increase the component of steel fiber to increase the strength of the fiber in order to recover the failure. Then, according to Weijie, used steel reinforcement concrete. They found that the concrete will fail due to the carbonation of concrete and correct penetration. So, they can use acoustic emission techniques of fiber optic sensor to overcome the corrosion of steel reinforced concrete in order to improve the strength of the concrete. Now we move on to the methodology part in this study. In this study, SolidWorks software is used to carry out the testing of prepared assemblies. SolidWorks software is used for planning of designing of modeling the test in 3D visual. So, in the preparation of sample, 5 samples of concrete will be made of different ratio of plastic waste. So, sample A is the control sample with 100% of fine aggregate. Sample B will be used as 20% plastic waste mixture, and in this study, soft plastic LDPE plastic and the hard plastic HDPE plastic will be used as a mixture in carrying on the test throughout the study. And sample C will use 40% of plastic waste, sample D 60%, sample E 80%. And after the preparation of the sample, SolidWorks software is used to simulate the result. And in this study, there are 3 types of tests will be carried out. The first one is the composite test and drop test, which is under the mechanical properties of concrete. Then, after the testing, we'll undergo a physical test, which is the failure analysis. So, after the testing, the data will be analyzed. Then, we'll come out with a conclusion throughout this study. In this study, the samples are designed in a cube by using SolidWorks software. And you can see here, the left-hand side is the control sample, which consists of 100% of fine aggregate. The cube is designed with a square and a 2D, and then we extrude the cube with a height of 100 mm. to make it into a 3D model cube. Then we assign the material into the cube. Meanwhile, for the another research sample, the right hand side consists of 3 parts. This part, the first part consists of fine aggregate. The second part, the blue color one, consists of LDPE soft plastics. And the third part, the red color one, consists of HDPE hard plastics. These 3 parts are assembled by using the SolidWorks software in order to make it into a plastic mixtures and fine aggregate concrete. Then the samples will undergo the mechanical testing by using SolidWorks software. There are 2 testing under the mechanical test, which are compressive test and then the drop test. In the compressive test, each of the samples will be tested with 6 different forces, which are 100 Newton, 1000 Newton, 2000 Newton, 3000 Newton, 4000 Newton, and then 5000 Newton. The range of the force will provide the strength of a concrete which can withstand the strength of nut. After we assign the force onto the samples, we will run the simulation, and after we run the simulation, we will have the result as you can see on the figure here. Then for the drop test, we will provide 4 different heights in the study, which are 1 meter, 2 meter, 3 meter, and 4 meter. Each of the samples will be tested under these 4 different heights. After assign the height onto the sample, we'll run the simulation. After run the simulation, we'll have the result as shown on the figure here. Then, after the mechanical testing, we'll move to the physical testing. Physical testing is tested by using failure analysis. Failure analysis will also use to define the physical properties of the concrete. By using the failure analysis, the problem, which is the failure of the concrete, will be identified, and then we'll compare the properties between the conventional concrete and concrete made from plastic waste. Then we'll identify the root cause of the problem. Lastly, we'll determine the corrective actions in order to provide a solution to prevent the concrete from failure or cracking or deformation. After the testing, the data from the compressive strength test, drop test, and failure analysis will be analyzed. Then, assess the mechanical and physical properties of conventional concrete and concrete made from plastic waste. The data will be tabulated by using Microsoft Excel. Lastly, the properties of the concrete made from plastic waste will be compared with the conventional concrete. So, the first objective will be achieved by using different ratios of fine aggregate plastic waste in producing a concrete. Therefore, the optimal composition of different ratios of fine aggregate plastic waste will be determined by using different ratios. Then, the second objective will be achieved by using the mechanical testing, compressive strength test, drop test, and then the physical test, failure analysis. After the testing, the physical and mechanical properties of different ratios of fine aggregate plastic waste in producing a concrete will be identified. Thus, the difference between the properties of concrete will be determined by using data analysis. Therefore, data analysis is used to achieve the third objective. So this is the reference from the slide. That's all for me. Thank you for your attention. See you soon in the Q&A session. Thank you and have a nice day.